Today we'll be doing the chain rule. The first problem we're going to do is this one. We have to differentiate the square root of x to the fourth plus x. Okay, so differentiating this, you'd have to change the square root first. You have to remember that the square root of, the square root of a is actually a to the power of 1 over 2, right? So the square root of a is the same as a to the power of 1 over 2. B will apply that here. So if we apply that here, we have find the derivative of x to the fourth plus x to the power of 1 over 2, right? And then when we differentiate, we do this. We say the outside function is something to the power of 1 over 2. So the derivative of the outside function would be found using the power rule, which would give us 1 over 2 multiplied by the inside function x to the fourth plus x to the power of, we say, this exponent minus 1, which will give us negative 1 over 2. And then this is just the derivative of the outside function. We need to multiply that by the derivative of the inside function. The derivative of the inside function would be the derivative of x to the fourth, which is 4x to the third, plus the derivative of x, which is just 1. Okay, that's your answer. You can go on to further simplify this by saying this has a negative, so it's 1 over that, but I'm just teaching you the chain rule here, not simplification. So B is d on dx of the cube root now of x to the fourth plus 9x squared. Let me say plus 1, but it's not important. Okay, we use the same rule here. We have a cube root. We have a cube root now. So we have d on dx of x to the fourth plus 9x squared plus 1 to the power of 1 over 3. Because now we have a cube root, so we have to divide by 3, right? Cube root, because when you take this and make it the exponent of all of this, the 3 goes beneath the exponent that was already there. So this, since this is all to the power of 1, you say 1 over the 3 that's here. That will be another video. Now we need to find the derivative of this. The outside function is something to the power of 1 over 3. So if we differentiate this in the same way that we differentiated before, we use the power rule to say 1 over 3 multiplied by the inside function, which is x to the fourth plus 9x squared plus 1. And then we need to say 1 over 3 minus 1, right? Minus 1. So that's 1 over 3 minus 1, which is 1 minus 3 over 3, which is minus 2 over 3. Because you multiply this by that to keep the same denominator. So the exponent is minus 3 over 2. And then we need to find the derivative of the inside function, right? All of this is just the derivative of the outside function. The derivative of the inside function would be the derivative of x to the fourth. The derivative of x to the fourth is just 4x to the third. The derivative of this 9x squared using the power rule would be 18, because it's 2 times 9 x to the power of 1 plus 0, right? Because the derivative of 1, or the derivative of any constant c, is just 0. You can go on to further simplify this as well, but I'll leave it there. Let me know in the comments if you want me to simplify the answers or should I leave them like this. I'm still not sure about this thing. Right, we're doing C now. We need to find the derivative of x to the fourth. Hey, why is it only x to the fourth? Actually, but let's leave it x squared plus 9 to the third power. Right, for this derivative, we don't need to change the square root or anything because we don't have a square root. We find the derivative of the outside function, sorry. The outside function is something cubed. So for the derivative of something cubed, we use the power rule. Since the power is a constant, we say 3 multiplied by all of this thing. Since we said it's something cubed, we need to multiply by the thing. X to the fourth minus 2x squared plus 9. Then the exponent will decrease from 3 to 2 because we're minus 1. Right, that's the power rule. You say 3, you multiply it with the front part, and then you minus 1 on the exponent. And then now we need to multiply this by the derivative of the inside function. The derivative of the inside function will be 4x cubed minus 4x. I don't know if this can be further simplified, but once again, this is a chain rule video. Now we need to find the derivative of cos² x. You need to remember that cos² x is the same as cos x or squared. Right, so the inside function is cos x, but the outside function is something squared. Right, it's something squared. If the outside is something squared, we can use the power rule to differentiate the outside, which is just going to be 2 cos x. Right, why am I not writing the exponent? Because it's 2 cos x to the power of 1 now. Because we were going to say, okay, let me do this. 2 minus 1. Because it's the first derivative, and therefore we have to say 2 minus 1. And then find the derivative of the inside. The derivative of the inside in this case will be negative sine, because the derivative of cos x is negative sine x. Now this goes on to be negative 2 cos x. This is just 1, so it's just cos x sine x. You can further on simplify this to say it's negative 2 sine. You can further on simplify this to say it's negative sine 2x, because it's 2 sine x cos x, which is the double angle for sine. This is the double angle for sine. So this is sine 2x. Therefore, the derivative of cos² x is negative sine 2x. You can memorize that. I don't know if they allow us to. I don't know if institutions allow students to memorize the thingies, but it's pretty fun. And you get to know when you made mistakes. Right, I'm no longer writing numbers because I lost track. But now we are differentiating cos squared 2x now. Okay, so this is a bit different, but we will conquer as we always do. This is the same as differentiate cos 2x all squared. How many functions do you have? First function is something squared. Second function is cos something, third function is 2x, right? We have these functions. The outside function is something squared, since we have the squared. The second function is cos something. The third function is 2x. Let me show you how to do this one. How you do this one is you differentiate the outside function, right, which is something squared. Use the power rule. You say 2 cos 2x to the power of 1, so it's just 2 cos 2x when you differentiate the outside function. Now we need to differentiate the inside function, just as the chain rule says. No new thing. So to differentiate the outside function, this is when it gets a bit tricky to know this, but it's easy to do. To differentiate the inside function, we would have to use the chain rule again, because the inside function has another function within it. So this is how we do it. To differentiate, we say, starting here, the derivative of the outside function is the derivative of cos b, which is negative sine. We know b is 2x, so 2x. And then we also differentiate the function within the cos, which is 2x. So differentiating 2x, you would use the power rule and say the 1 multiplies with the 2, and then you subtract 1 from the exponent of x, which gives you 0 for the exponent of x, and this goes away, and you just have 2. Okay, so this is the derivative of this. It's 3 functions, so you have 3 derivatives. You have the derivative of the outside function, and you have the derivative of the inner outside function, and you have the derivative of the inner inside function, I guess. But those are not official names. I'm just making stuff up, as I always do. Just kidding, I don't do that. But let's go to cosec squared x. We are finding the derivative of that. Now, how do we find the derivative of cosec squared x? How we do that is we first realize that cosec is a function that is based on another function, and it's also squared. So let's first deal with the squared, at least. d on dx into cosec x squared, right? We dealt with the squared. Now what we'll do is say d on dx of still bringing the squared, right? Inside we want to write the co-function of this. The co-function of cosec is 1 over, how I memorize them is that it's not what you think. This looks like it's going to be going with cos, and therefore it goes with sine x. That's basically, I mean, that's memorizing, but it works. And I say it's not what you think, because when you look at this, you think this is cos, and therefore it should go with cos. If that's what you think, then that's wrong. Therefore it should go with sine. Because I tried learning why it's called cosec, and they gave me weird reasons, and I didn't understand. But I'm gonna learn again, and I'm gonna tell it to you guys one day. Right, now we need to find the derivative of this. How do you find the derivative of this? Two ways. I want to use them both, but okay, let's not use them both. Let's use the chain rule, which is what we said we were going to use. So using the chain, oh my god, I just realized something. I need to note it down. I'm going to show you how we found the chain rule in another video. Okay, sorry. Let's continue. This one, we need to find the derivative of the outside function. It's something squared. So you say 2 times the inner function, which is 1 over sine x. This is still cosec x, right? Derivative of the inside function now is 1 over sine x. 1 over sine, 1 over sine x is differentiated using the quotient rule. And the quotient rule says you take the denominator, you square it beneath. So let's have sine squared x. And then here you're going to have sine x, which is the bottom, multiplied by the derivative of the top. Derivative of this is just 0, right? Which means this is all going to go away. Times 0 minus the top, which is 1. I don't need to write 1. Multiplied by the derivative of the bottom, sine x. The derivative of sine x is cos x. That's what you have. Now, this, okay, let's continue. You have 2 times, this is cosec, right? Cosec. And then this goes away. We don't have this. We have cos x over sine squared x. So I want us to write it like this. I want us to say 1 over sine x multiplied by, I'm doing the simplification for these because I think this is the one that we are not used to as compared to the other ones which we are used to. So I just want to do this so you get to know how to do it. Cos x, I say negative here, cos x over sine x. Why am I writing it like this? I want this to be something. I know this is cot. It's cot because tan is sine over cos, and the inverse of tan is cot, and this is also the inverse of tan, and therefore this is cot. How does this relate to that? Well, we have the negative. If we multiply everything out here, we're still getting the negative sign. We have sine and sine at the bottom, which will give us sine squared. We have the cos, which will give us that cos, and therefore this is equivalent to that. Now, when we simplify, we take the negative to the front because we are multiplying everything anyways, so it will still be accounted for. This is 1 over sine, which is cosec. This is cosec, so you have cosec x multiplied by cosec x times cot x, and then you have minus 2 cosec times cosec is cosec squared x times cot x. That is your answer. It's better. Usually the most simplified version is the one that doesn't have any division, so I think this is the most simplified version of this. Alright, let's continue. The next one, where did I write these questions? The next one is, I don't think the next one's gonna fit on this page. Next one is differentiate cos 2x tan x. Right. As you can see, here we have cos of something multiplied by tan of something. That is the product rule. That is what we are going to use first. That's the product rule. So how we are going to use this as a product rule is, well, there is another path you could take with this, where you separate this into 1 minus 2 sine squared x, and then that in brackets multiplied by tan x. That would get you to the same answer, I believe, as the method I'm going to take now. But I want to use the method that just differentiates this directly. Using the product rule, you say one of the functions, let's say cos 2x, multiplied by the derivative of the other, derivative of tan x, d on dx tan x, and you add tan x multiplied by the derivative of the other, cos 2x. That's the nice thing about the product rule. You don't have to care which one starts. You don't have to care if you started with this or started with that or starts with that, like, because you're adding anyways, and adding doesn't care about who comes first. Okay, now we just have this, which is cos²x, and the derivative of tan x. I memorized this somewhere, but let's just do it straight up. Let's do it. D on dx, sine x divided by cos x. We will differentiate it like this. We have sine x over cos x, then we'll use the quotient rule. But if you know the derivative of tan x already, just skip the video. Skip this part and go to the part where we are done with it. Plus tan x d on dx cos²x. Now we need to differentiate this. To differentiate this, we'd have to differentiate the outside function, which is cos of something. So that's negative sine 2x. And then we'd have to differentiate the inside function, which is 2x. And the derivative of that is just 2. Right. Now we have cos 2x. If we're differentiating this using the quotient rule, we have cos²x as the denominator, and the numerator will be cos x multiplied by the derivative of sine x, which is cos x, minus sine x multiplied by the derivative of the denominator, which is negative sine x, plus, okay, you should have put minus there, but it's not important, tan x negative sine 2x times 2. Okay, now we just need to simplify. This is the answer. This is a answer. Okay, yeah, let me say it like this is a answer, but we are simplifying it now. To simplify this answer, we have cos²x. This is cos²x because cos x times cos x. So cos²x. This is a negative times a negative, which gives us a positive. And this is sine times sine, which is sine² x. This is 1. Plus, shoot, I forgot to put a negative again. Fine. Tan x negative sine 2x. 2. Right. Now we say this is cos 2x. The sum of these will give us 1, because it's sine² x plus cos² x is 1, divided by cos x. Okay, I'll show you now what I'm doing. I put a squared there. The squared, I put it there because we already had 1 on the numerator and we had cos² x on the denominator. So I took the squared out, because even if you distribute the squared, you still have 1 and you have cos². And the reason why I'm doing that is so that I can insert or substitute the cofunction of cos x here. Now I remember to put the negative sign. Yes. I'll start with sine 2x just because it looks cooler, but there's no specific particular reason. Tan x. Okay, I should start with the 2. The 2 goes to the front because normally we have the constants in the front of the variables. Right, final step, I think. Cos 2x. Now what's the cofunction of cos x? The cofunction of cos x is the one you don't think is. So it's not cosec, it's sec. Sec, but it's squared. Squared x minus 2 sine 2x tan x. It's possible that there are other ways to simplify this, I think it's highly possible. Say maybe you divided the ton, but let's not get into that just for the sake of keeping the video short. But I am tempted to do it. I just don't want to make the video too long. Nah. Ish. Okay, let's do it real quick in our heads. This is going to be sine over cos, and this was already cos² at the bottom. We take cos as the denominator. We just need to multiply by 1 cos this side. I don't think it would have been simpler. It would be something else, but it wouldn't have been simpler in my opinion if you change that. Right, let's do the next problem. The next one is d on dx of, oh, it's actually the last one, sine x plus 1 squared. Right, so x plus 1 is squared. How do we do this one? Simple chain rule, guys. Do not panic when you see these complicated functions. You just need to know how to decide on the outside function and the inside function. In this case, the squared is not in front of sine. Here, it's not here, which means it's not like this one. It's not like this one where we had cos x all squared. It's different from that one. In this case, we just have x plus 1 squared. So it's the angle that is squared. It's not sine. It's the angle. It's not sine of the angle that's squared. So in that case, the outside function is just sine, right? It's just sine. It's not sine all squared, or it's not something squared. So the derivative of the outside function, which is just sine, is cos of the inside function. So cos x plus 1 all squared. Understood? Right, I know you understood that because you are an awesome person. Now we are doing the derivative of the inside function, which is the angle squared. Right, the inside function, we have two inside functions in fact. It's something squared as well as x plus 1. So the derivative of the first inside function, which is something squared, we will use the power rule and say 2 times the inside x plus 1. This is to the power of 2 minus 1, which is just 1. Now we need to differentiate the inside function, which is x plus 1. The derivative of 1 is 0. We don't care about it. The derivative of x is 1. We don't care about that either, since we are going to multiply with it. So, but probably write it just in case. Then now you have this. I don't know if you can simplify this in any way. Yeah, I think you can just say 2x plus 1 cos x plus 1 all squared. Right, that's it for this video, guys. Please do your thing. You know your thing is subscribing, because this is the amazing channel you guys find the content you want in. Send me emails if you want me to make a specific video, you want me to explain something, you have any questions, you want to talk about something, email me. My email is mamamediart@gmail.com. Thank you.